Okay. So let's pick up where we left off last time. So at this point, everybody should have Android Studio on your computer, and I'll actually go through the process again, then we'll add some stuff to it. So let me, and actually well, here, let's just go this route. So we'll put up Android Studio. Okay. So what I'm going to do here is I'm going to create a new project. So I'm just going to start from scratch so you guys can see the whole process here. Actually, I have a couple of different things open. So I'll create a new project. I will make this around an empty activity. That's what I'd like to start with. And I am sharing my screen, right? Okay, so I'll make an empty activity. Click next. You can name this guy whatever you want. I'm actually going to, well, Android, I can put it in my Android Studio projects. That's fine. So I'm going to call this guy CSC250. Call this Android 1. Okay. So just whatever. I'm just giving it a name, and I'll save it in my Android Studio projects just in a different folder. I choose Java as my language. Notice there's another language in here called Kotlin that's like a Swift competitor. I think actually Kotlin came out before Swift, but doesn't matter. We're using Java as our base language, which is what all Android applications are currently written using, and I foresee them being written in Java for a while still. Minimum SDK, this is, what percent of devices it'll run on. Notice that if I use API 16, that means I can only use things that were available to Android up to API 16. Notice there's a bunch more since then. So, if I want to use the latest, greatest features that just came out, I can go to API, 28 or 29, but then I'm going to cut my number of potential users way down. We're only doing very simple things in here, so API 16 is fine. We're not going to be using any of the glamorous features because we're not focused on Android development. We're really focused on Java, but seeing it being used in a different context. And then if you want to take that to write a bunch of Android applications, you certainly can. This will give you the background to do it. All right, so now I'll go ahead and hit finish, and this is going to create for me a starter application with two things that are important to us initially. This thing called main activity, which is a Java. This is a controller. We talked about MVC last time, model view controller, where our view is our user interface. That's this guy. That's this activity main.xml. And then we have this thing called main activity.java. This is our controller. The model would be the database part of this, which we will be looking at probably not today, but maybe Thursday or next week, connecting this ultimately into a database that we can then remember stuff. So keeping our data in one place, keeping our user interface in another place, and keeping our controller, our logic, in another place. Hey. Okay. So in any case, this guy already is working. I'm just going to get it running, and then we're going to walk through how it works, and then add some stuff to it. So I'm going to go ahead and hit play here. Notice I already have, if I go to my window, is it window or is it tools? Avd Manager. So I already have a pixel device. In fact, actually, why don't I just delete this? Is there a way for me to delete this from here? Yeah, I'll delete this guy. So this should look exactly like your thing first looked. So I'll go ahead and create a virtual device. And doesn't matter which one you pick. I will pick a that's what a Pixel 4 is what I'm going to choose a Pixel 4. So you know, basically this is just giving you more about screen sizes and things like that. So you know, you can create all sorts of different devices on here. Notice these earlier ones, these were like kind of generic screen sizes with resolutions, but you know, now it's become more of what Android is built on top of. It used to be Nexus phones, now it's the Pixel phone. So I'll just create the latest, greatest. I could do a Pixel 4 XL, but that might be too big on my screen. Let's just do Pixel 4. Okay. Now notice here that it has, you know, it's asking me to select system image. What this is saying is what version of Android do you want running on this fake device? Well, if I were to go out and buy a Pixel 4 today, it would be running API level 29 Android Q, which I already have downloaded. It really doesn't matter which of these you download because they all are higher API levels than we're developing for. We're developing for 16. So basically, if you already have one that has already been downloaded, just pick that. Otherwise, you can download any of these other ones. For us, we're just picking whatever's the most convenient. So you want a x86 image of something that's already on your computer that is at least API 16. All right, so I probably would not download the very, very, very newest thing that could be a little buggy. So anything that's down below that, but they're all probably fine. All right, but I already have Q downloaded, so I'm not going to do any extra downloading or anything. So I'll just select that, hit next. It wants to know what I want to name it. If I want to customize anything, I'm just going to leave it alone. Just make it a stock device. I'll hit finish. And there is my virtual device, my Android virtual device. All right, so I can go ahead and close that if I want. Notice when I hit this play button, it already has my virtual devices on here. I can also have it run on multiple devices. I know some of you used a USB cable and plugged your Android device into your computer. You could also run directly on your Android device. In fact, for many of you, that's actually probably going to be the fastest way to run stuff. But then it also requires that you have an Android phone and all that stuff. But the emulators are pretty good, but like I mentioned last time, some of you are likely going to have a couple of hiccups with the emulators until you get it figured out. So use Google and stuff like that. But in any case, we should now have a running application. I'll go ahead and hit play. It's going to launch this emulator if it's not already launched. Is my screen still being shared right now?
Yes, you're good.
Yes.
My whole screen just went black for a second for some reason. It's good. It's good again. I was wondering if that was Zoom dying a slow death. All right, so there's my, well, it's in the process of finishing launching it. So there's my Hello World application. All right, so that should have been the whole process of what you would have gone through to get this running on your computer. If you got any emulator issues, then what you'd want to do is Google those particular errors or put it up on Slack and see if anybody else in the class had the same problems. The most common one is you need to turn on virtualization on your computer's BIOS, which has you just reboot your computer once and press like a button like delete or F8 or whatever your particular computer brand's special key is to get into the BIOS, and then just select turn virtualizer on, and then that fixes many of those cases. Some of the other ones are some driver issues where you need to have the latest, greatest, or even in some cases, not the latest, greatest. You need to have a very specific version of some driver like that. Okay. Now, one thing you may have noticed is that if you are running the Android emulator and you're running off your laptop's battery, your battery does drain faster because you're running another computer inside of a computer. So this is similar to what you had last semester in 200 when we were running Raspbian in a virtual machine. You have another computer running at the same time, and while Raspbian was built for pretty small devices, you imagine Android Q is probably a more robust operating system than that, and maybe taking up even more system resources. But in any case, just something to consider. Like the fans in my computer just kicked on, and I have it plugged in right now, but my computer is a pretty powerful computer, so all of your computers are very likely going to be using some extra system resources when you're doing Android stuff. Okay, so now it only took a long time to launch that particular time. So if I go in, I'll just update my activity main, and I'm going to change the text on this guy just for a second here. I'll talk about how to do all this later. So I just changed it to Woot. I hit play again. And there it is with Woot. Launches much more quickly the next time because your Android device is already booted up, so to speak. Okay, so questions about any of that stuff up to this point? Okay, so now what I'm going to do, I'm going to go up to, somebody had asked whether this was going to work with GitHub, and the answer is yes. But I want to see if I can do this directly. Okay, yeah, so I'm going to import into version control. So this is from within Android Studio. And let me explain a little bit why we're doing it this way. There's nothing that keeps us from doing the same thing we did for Eclipse, where we create a folder, we go ahead and put that folder in. In fact, if I go through the motions there, let's go into our GitHub desktop, and I'll go ahead and add a new repository, and we'll put this guy in downloads, and we're going to call this guy a sample Android repo. Now down here with Git Ignore, I haven't looked at this yet, but I presume I'm going to find it in here. Git Ignore is a collection of configuration files for which things we should get ignored when storing. Now, Android, when you have an Android application, a lot of things are generated during runtime or right before runtime. These are things that don't necessarily need to be stored in your repository. They're not code you wrote. Instead, they're code that are just part of the Android OS or ecosystem. So rather than storing a whole bunch of extra crap, it'll just let Android Studio fill in those gaps when it first launches. So we want to turn on the Git Ignore for this. And specifically, it's going to be Git Ignore for Android. So you'll choose Git Ignore for Android. And what that'll do is it will ignore any files that are in your folder that are things that Android automatically builds on it, that it builds on its own, so that you don't have to store things that are just going to get rebuilt anyways. So that would be one way you can go about it. You can create your repository just like before, but built into Android Studio, we have the ability to import into version control. So I can go to VCS. I could say I want to import into version control. Now I can create a local Git repository. I could also just say share project on GitHub. So it's getting my account information for GitHub. I had already logged in here. So the first time you do this, you'll have to put your username and password for GitHub. So this is like an alternative to Git Desktop because it's actually built into Android Studio. So here's my repository name. I'm going to keep the private unchecked. It's going to be called origin, so I'm not going to change anything here. I'm just going to say share. Name should consist of letters, numbers, dashes, underscores. Okay, so I have to put dashes in here. It doesn't like the spaces for my repository name. I'll go ahead and hit share. And now it's doing its stuff. It's showing me the things that it's going to put in there. This is the initial commit. Okay. Then I'll just hit add. That added them to the repository. Now it's publishing it. It told me it successfully shared it on GitHub. So if I click on this, it'll take me to my GitHub thing. And here is my application on GitHub. And as we make changes, I'll push the changes to this as well through Android Studio. So actually, Android Studio makes it easier to integrate with GitHub if you use their built-in thing, but nothing prevents you from doing it the generic way we did last time, because that'll allow you to do that for anything. You know, you have a big, and keep in mind, GitHub isn't just for code projects. It was built for that, so you can show the differences between files and stuff like that. But really, GitHub can store any kind of data type. So if you want to, you know, you have some big group project in a, you know, psychology class or something like that, nothing keeps you from sharing all those things between people using GitHub. Okay. So in any case, that's how you can put it up there, but that also gave me the opportunity to kind of introduce the Git Ignore thing. And there's Git Ignores for all sorts of different stuff, like Unity. Unity is a big one. So if you do any game development using Unity, which we might actually look at, I don't know, one of my classes will do something with that. It's going to basically be the same experience you're doing right here. You already know Java. Now we're just applying it to Android Studio. Next semester, you'll have 370 with Dr. Locklear, and you'll be doing some C# development in there, which is effectively identical to Java. Well, Unity, the Unity game engine uses C# for its scripting. So what you'll be doing is you'll take your C# skills, bringing into Unity, learn how to make video games by dragging and dropping stuff and controlling the stuff using your C# skills. And Unity has model view controller, just like Android has model view controller. You make your interfaces with their little 3D drag and drop animation stuff. You have your controllers, those are your scripts in Unity. And then if you need to store stuff externally, that would be in your database. So these base skills that we're learning can be applied to all sorts of different things. I just happen to be choosing Android Studio here because it's using the identical language to what we've already been using this semester. We're just seeing how we can put this into a different ecosystem. All right, questions about any of that so far? Okay, so for starters, let me minimize a couple of things here. This will make this a little bit bigger. So I mentioned, actually, I want to go to the project first. So if we look at the organization of your project over here on the left, so it creates all this crap for us. We have this thing called the Android manifest, which you might have to mess with. We probably won't, but this allows you to like add certain security protocols and stuff like that, because basically Android applications are completely locked down, kind of like when we make all of our fields private in our Java classes. And then we can loosen the reins. We can give it access to the internet. We can give it access to GPS, things like that if we need to. We're not going to be writing very complicated things in here, so we probably won't have to do this. But this manifest folder and this file is an important file. So then underneath the Java, notice some of these things say generated next to it. So anything that says generated are things that we shouldn't be touching. That's built into like the Android ecosystem. So under our Java, this is our actual code. Now we have Android test and test. This is something called unit testing. But we're going to just focus on this. This is our main activity. Now, last time I talked about the generics of an Android application, where an Android application is effectively a collection of activities. You can pretty much think of an activity as a screen in your application. You know, that's a little bit not 100% accurate, because actually applications still exist in like a greater virtual machine, kind of a pod that keeps one app separate from others. But all intents and purposes, you can think of an activity as a single screen of your application. If you were on a on iOS, this is a UI view controller. That's the kind of animal that's equivalent to an activity in Android. It's called a UI view controller in iPhone development. So an activity is a collection of views. iOS, these are called UI views. One of the things I want you to take away from this is, even though we're learning this in terms of Java and Android because it'll run on everybody's computer, if you are an iPhone person and you have an iPhone and you want to mess with writing software for your iPhone, the tool is called, instead of Android Studio, it's called Xcode. It's free from the Mac App Store, and you can follow a pretty similar pattern to what we're doing here for writing iPhone applications. Once you get past the initial, you know, couple of different ways that handle some things, you'll see that they're very similar. Okay. So this is effectively what an Android application is, and we're seeing that in practice over here, where we have our main activity. This guy is the dude who drives our program. This is our controller, and I'll come back and look at this here in a few minutes. I'm just kind of giving you the intro to the stuff over here, and a lot of these things you probably saw in the tutorial if you went deep enough into it, but I'll just go through it again here. All right, so we have our controller from our model view controller. This guy controls a view. That view is stored inside of this folder called resources, RES, and it's inside something called a layout. So drawables, this is where we keep our images for our application. Layouts are where we keep our actual screens of our application. Values, we have a string XML thing that allows us to have, like, for multi-languages and stuff like that, and also colors. So these are, you know, collections of things where we can change it in one place and not have to change it on every screen of our application. So maybe we use something from our values strings for like the version number, and then maybe it's on 20 different screens on our application. Well, rather than go and have to change those 20 screens, we can just change the version number inside of our string here, and that will then translate to the rest of the application. So if I go into strings, notice here the string name is CSC250 Android 1. And that's what shows up here. But if I change this guy to LOL, I don't even have to go in and go to that screen where that thing was set up. I now have LOL up there, because this guy was set up to read whatever the name of whatever the app name was from the strings XML file. Okay, so generally speaking, I don't use this very much. I mean, if I were writing a professional Android application, maybe I would, you know, where I'm really thinking about the final deliverable. That's something you'll talk about in the software engineering class, but in here we do a lot of kind of smaller puzzles and little examples. So I tend not to use really anything from it in here, and very little withdrawables, because I don't focus too much on the interface. So if you want to put images and stuff like that into your application to make it look pretty, that's fine. But we do mess with the layouts a little bit. So we can think of the layout as the view that is part of our user interface. So this guy is called activity_main XML. Now, one of the things I mentioned with MVC, let's go back here. MVC says it's a good idea to keep your model, your view, and your controller separate, and then have some mechanism for allowing them to communicate. Okay, so we need to learn today what Android's mechanism is for allowing the controller to know about the views, to know about the models. We're not going to see the model part yet, but we're going to see the controller and the views. That's what we're going to be focusing on today. So if I go back into Android Studio, so right here, I have this thing called activity main, and I want to change this a little bit. So design surface, so the default is design plus blueprint. I just want design. Design plus blueprint might help you if you're writing some very complex interfaces that you really need to see what's happening behind the scenes, and then see kind of the what you see is what you get version of that. But none of my interfaces are ever that fancy. So for those of you who really want to get into interface design, that's kind of stuff you'll talk about in the human computer interaction class, CSC250. And then also if you want to pursue that on your own, I mean, it's not that it's not important, it's just not part of computer science. Making things look good is maybe a more of a multimedia graphics design type background, and those people play an important role with the computer scientist who maybe makes things work well. Now, some computer science folks have the ability to make things look good as well, so maybe they're a little bit more of a one-stop shop. But generally speaking, when you get up to the professional level, you're going to have graphic designers making your interfaces, and you'll have computer programmers making them work, because each of those people then are working in their expertise field, as opposed to maybe you have a graphic designer who can also code. They might even be very good coders, but chances are their real special sauce is in the graphic design. Similarly with the programmer, you might have a programmer who is pretty good at making graphics, but their real special sauce is probably in their coding abilities. All right, so I don't go very deep into interface design here, partially because I'm not overly great at it, but secondarily, from a programmer's perspective, we want to focus on making things work and then having at least reasonable facsimiles for our interface initially, and then somebody like a graphic designer can come through and give us an updated user interface that we then just have to hook up. And by the end of today, you'll know what I mean by hooking it up. All right, so the first thing I'm going to do is, this thing is something that's happened more recently. So I know I asked this last time, and we don't get great user feedback with these things, but let's say Android versus iOS. Let's just roughly say that half the people are Android users, half the people are iOS users. It's a little bit more heavy on Android now, but when you look at flagship devices, it's pretty much half and half. So the people who have Android devices that are from the last 2 years versus the people who have iOS devices from the last 2 years, these are roughly equivalent to half the population. There's just a lot more Android devices floating out there, which was some of the original complaints, or some of the original things iOS used to poke fun on them for. You maybe have heard of this idea saying Android is too fragmented. This is what iOS people used to complain about. Do you know what it means for them to say Android is too fragmented? Anybody follow this? I mean, it's been gone now for enough years that we might have missed this particular generation. But anybody happen to know what I mean by that? Android is too fragmented?
Too much variety?
Yep. Okay, there, and do you know what that variety would, what form that variety would come in?
Devices owned, like just so many different devices owned.
Yeah, so, we've already seen a little bit of this, so we might say too much variety in terms of installed OS. We already saw that, right? The API level, 16, 17, 18, whatever. You go out and you get 10 Android devices from 10 people on the street. There's a pretty good chance you're going to probably have 4 or 5 different operating systems running on them from different vintages. Because every year Android comes out with a new OS. But only certain Android devices will automatically get that newest OS. So the Pixel devices automatically get the newest. The other flagship devices like Samsung Galaxies, they typically get it with a delay, but also they've also modified it in some way because Android's open source and Samsung likes to put their own extra stuff in there, like Bixby. Bixby is Samsung's version of Google Assistant, which is Google's version of Siri. So, I mean, I run a Samsung Note 10 Ultra, and I have well, at least this one no longer has a special Bixby button, but I never use Bixby. I use Android Assistant, but I don't necessarily care. Just if you already have Android Assistant or Google Assistant, why do you need Bixby? I'm not sure it's really solving a problem that we had. But in any case, so we have a lot of variety. Installed OS is one of them. Screen size is another one. Pixel density is another one. That's the number of pixels that will actually fit on the screen, regardless of the screen size at the time. And I'll just throw an etc. in there because you also have, resolution differences. Some are wider, some are taller. Their tallness relative to their wideness is a different aspect ratio than other ones maybe would have had. Stuff like that. So really what this means is if you're writing software for an Android device, it's your interfaces tend to be a little bit less polished. If you've been an iPhone user and you've been an Android user, you maybe have noticed that the same applications on iPhone typically look more polished than the equivalent application on Android. And this isn't because Android is junky, it's because the developers who wrote that application for Android were having to write it to work reasonably well on a larger combination of devices. Kind of the, just par for the course. It's not that they're junkier applications necessarily. But now the funny thing here is that Apple used to complain about the fragmented nature of Android devices. They don't complain about that anymore because now iOS has, it's not fair to say they have as much fragmentation as Android because Android, there's Apple is the only company that sells iOS devices, as opposed to Android devices comes from a whole bunch of different companies. So each one of those companies has their own internal variation on screen sizes. Now every phone that comes out, there's a normal and an XL version of it, things like that. And now we also have different categories of tablets. So for Apple, you have, an iPad mini, then you have like the normal size iPad, then you have the super size iPad with the giant screen. So you have some different screen dimensions. You also, generally pixel densities and aspect ratios for Apple have remained the same for at least prolonged periods of time. But at the very least, Apple can no longer say that, oh, every single one of our devices is a 3.5-inch screen, because that's what it was, or 4-inch screen. So there was very little fragmentation on iOS devices in the early days. And even when they went to a Retina display, a super high density, pixel density screen that made it, let's say, higher definition, all they did was double the number of pixels. So the aspect ratio still stayed the same, is kind of the punchline. But they can no longer say that. So, iOS no longer can say they are not fragmented. But they are still less fragmented than Android. But being less fragmented doesn't really mean that much, because you're still creating this new complexity around the application developer. When they write their applications, they have to write the interfaces with the idea in mind that the person who's running this application might be running it on different kinds of screens. Some applications are available only on the phones. Some applications, you can get the same applications on the phone as well as the iPad. iPad can also run just phone applications. It runs it like in a phone mode. So you can get an application that was meant for iPhone and still run it on an iPad. But a lot of those applications also have iPad specific screens. And then on top of that, you can also write apps for Apple TV. So now you can have Apple TV kind of screens and the widgets that make sense in Apple TV. The same thing's true over in Google. Google has also Apple Watch. You can write stuff for Apple Watch. Google's equivalent is Google Wear, Android Wear, where you can write stuff for that. There's also Android TV, so on and so forth. So there's all sorts of different screens that a developer might write stuff for. And as we have more and more screens and more interface decisions to make, that's where it becomes, let's say, more important for a computer scientist. I'm going to call it a more well-rounded computer scientist, which might not be fair. You can go and ask Professor Locklear his opinion on this, but generally I would say that a computer scientist who has a strong interest in human-computer interaction is probably a more well-rounded computer scientist who is approaching technology maybe more holistically, as opposed to a, let's call it an old school computer scientist who is effectively a software developer, who at some point is going to say, I no longer have special talents in making my interface look good. So I'm going to leave that ability to somebody else. So what I'm really getting at is that in professional software development, ultimately the person who's going to be in charge of making your application look great on different devices might not be the computer scientist. It might be a graphic designer or somebody else who's going to have that skill set, maybe working with Android Studio or working with Xcode for, because now most of these guys have a type of layout called a constraint layout, which allows you to kind of work with things that, you know, like maybe you want this guy. So right now he's, you know, he's kind of, this guy pushes them to the middle, this guy pushes them to the middle, this guy pushes them to the middle, this guy pushes them in the middle. Now, if I change the size of my screen here, he would still be in the middle because you have these different constraint things all pushing on this one widget, forcing it back to the middle. So they've had to approach this, I'm going to call it a more complex way of building user interfaces, because there's now a new specialized skill that needs to exist for making your application look good on multiple size user interfaces and multiple different screen orientations and that kind of stuff. So as this has become more and more complex, I think that not that there can't be computer scientists who possess this ability, I would probably say that person is likely a more well-rounded computer scientist. And this isn't a you know, a smart or a stupid comment. This comes down to where they've spent their time in learning. If you spend 100% of your time learning software, you're probably not going to be necessarily great at user interface design. Or if you split your time between software development and user interface design, you may not necessarily be as strong in either of those as somebody who spent all their time in them, but you might have a skill that is you know, more of a one-person shop for creating applications or something. So I don't want to necessarily advertise as one as being better or worse than another. But there is a aspect to that. If you really enjoy programming, then you might say, okay, I'm going to put all my time and effort into becoming a master programmer, and I'll rely on somebody else to make my user interfaces look reasonable. If you are somebody who says, you know what, I don't love programming, I like it enough that, it's something that I could do, but I want to be somebody who really can contribute to the entire project, not just the making it work side of things. If you're that type of person, then maybe you become more of that jack of all trades and you develop the design experience. And, you know, at that point, maybe you're weaker on the programming side than somebody who spent 100% of their time on it, but maybe you are a better commodity for, you know, a marketing agency or you know, some smaller businesses that don't necessarily have the money or the resources, other resources to have, you know, a specialized programmer and a specialized designer. They kind of need to get both people inside of one human and then adjust their expectations on what they're going to be able to develop. So just some things to keep in mind. It's not a good or bad thing. It's just a thing. But in this class, since this is a programming specific class, and also because I'm not any good at it, we're going to pretend like constraint layouts don't exist. So what I'm actually going to do here is, so when I come over here to my activity main, I'm going to highlight over this component tree. I'm going to right click. This used to work at least. Let's see if it still works. I'm going to say convert view. And I want to convert this to a linear layout. All right, so now this guy is now a linear layout. All right, now linear layouts are substantially easier to work with, but also take away some of your ability. We have linear layouts come in two different forms. They have an orientation. So when I click on my linear layout here, over on the right under attributes, we see we have something called an orientation. If it's a vertical orientation, as we drop stuff into the layout, it stacks them on top of each other. So I made it vertical now. I'll just go ahead and start dropping some buttons in here. So notice how it's laying them out vertically. But if I go and I change this vertical linear layout, I change it to a horizontal linear layout. Notice it now puts them right next to each other. I promise the other ones are off the screen over here, and we'll eventually talk about why. It has to do with how these guys are actually laid out. So the layout width for this is match parent instead of wrap content. So match parent says match my width to the width of whoever my parent layout is. So the layout for this parent is the horizontal linear layout, which goes the entire width of the screen. If I change my layout width for my 3 buttons to not match the parent, not match the width of the screen, but instead be just big enough to house the names that are on my buttons, the content of the buttons, notice now they fit. Okay. Now, if I leave my buttons for wrap content and I change my horizontal linear layout back to a vertical linear layout, notice they still only wrap. They don't go the entire screen. Now, you can also put linear layouts inside of linear layouts, hence that whole parent thing. And we'll get back to that here in a second. Let me just keep making our connection. But this is our user interface. This is where we build our user interfaces over here. Okay. And we're going to do these guys with vertical and horizontal linear layouts to make our application simple, have simple user interfaces. If you want to go, I will not be grading any of your user interfaces. They just need to be functional. 2 text boxes for input, a button that when you click, it makes the logic happen. That's going to be good enough for what we're going to do. I just wanted to show it to you in this thing. If you want to go to town with your user interface, have at it. Okay, so let me just delete a couple of these. Actually, you can delete them in here if you want. Sometimes you find it easier to work with the component tree here. Other times you find it easier to work with it over here. There's also a way of viewing the actual code behind, and we'll look at that eventually. All right, so we have our string in here just woot right now. And if I were to run this application, it'll just have woot in the upper left-hand corner rather than It just asked me if I wanted to kill the previous running application. So there's my woot in the upper left-hand corner. Sometimes the emulator won't pop up on its own. You have to just switch over to the screen for the emulator. So there's my woot in the upper left-hand corner. All right, so now when we talked about MVC, we talked about the idea that it needs to, MVC model view controller says you should keep those three components of your application in separate places and then come up with ways to connect them to each other. So the question is, if I'm designing what my screen should look like for my activity, how does my activity actually become aware of this screen? So we're going to go into our main activity. And I'm going to fix the curly braces here because I hate them organized like that. And we're going to see here that a main activity extends something called an app compat activity. Doesn't matter what that is. We just know this is a Android built thing for a application compatible activity. And I've already said all of our screens in our applications are made up of activities. So we have our own main activity here built on top of our Android's built-in activity, whatever that means. All right. Now, all activities get this function called Oncreate. And this has something, I'll just come to put it on a slide, but we're not going to talk about it too much right now. But we're going to call something here Android application lifecycle. So, and the same thing is true here for iOS, that we have entry points into our applications for when we want certain things to happen. So for instance, we have, and I'll actually just get this. Let's go here. Android application lifecycle. It shows all the Oncreates and stuff like that. All right, so notice here when an activity starts, the first thing that happens is this function called Oncreate gets called. This happens before it's even on the screen. Then something called onStart, then something called onResume, then the application is actually running. Okay, when you switch to a different screen in your application, that guy, so another activity comes in front of the activity, so another screen happens, then the current activity pauses. Now, that activity, when it comes back in, like you hit the back button, let's say, that then goes to on resume before it shows up again, so on and so forth. So we have, that's only if it's paused, but if it completely stopped, then it goes through on restart, then on start, then on resume. So that it gets stopped when you leave the application and then come back to it, not just leave to a different screen in the application. But punchline from this picture here is that we have multiple places where we can interject logic. So notice here that Oncreate only gets called one time. You can think of this as almost like the constructor for an activity. So this guy only ever gets called one time. And when we Oncreate that, that happens before it shows up on the screen. And it also happens before onStart gets called. Now, onStart gets called when an activity first starts, as well as when an activity is coming back from the dead, let's say. So this guy might happen more than one time. OnResume has an even better chance of happening more than one time, because it can also happen when an activity was just paused due to like a pop-up or something like that, when this activity comes back into the foreground. So we have these different points of time that we can add stuff. For instance, maybe our application has some animation, just something that's moving around the screen or whatever. We're not really going to work on that stuff. Let's just say that's something we only want to be happening when the screen is actually visible by the human, right? no sense us having things animating behind the scenes when the human being can't see it. So we would maybe put that animation start stuff inside of onResume. You know, maybe inside of Oncreate is when we would start retrieving our initial data for, you know, the pieces of information we want to put onto the screen, that type of thing. All right, but this is the Android application life cycle. We have different points in time in which we can intervene with an activity. iOS has the same type of setup. They just have different names, but you know, that's kind of the go-to move for graphic user interface applications in kind of modern development. You know, when something is being born behind the scenes and the human doesn't see it, we might handle things differently, do things differently from a visual perspective than they would when the human being first actually sees it. Okay. So just kind of throw that out there. This is nothing you're going to have to memorize or anything, but we're already seeing this very first guy here. So he must be pretty important. The onCreate. It's kind of our constructor. All right, so we have this function here called onCreate that automatically gets called in terms of a Android activity. Okay, so somebody else is calling this guy. We don't have to worry about it. But what we're going to do is we're going to go ahead and we'll tell our parent. We already know about, so this is how an object refers to itself from within itself. Super is how an object refers to its parent from within itself. We know that main activity's parent is this app compat activity. So we'll go ahead and tell our parent to call their onCreate and do any sort of magic that a generic activity needs to do. But then we'll do the part that makes us special. And I like to put this in front of this. So we're going to say this activity is going to set his content view to r.layout.activity_main. So I mentioned MVC says it's a good idea to keep your model, your view, and your controller in separate places and then give a way for them to talk. This line of code right here allows this particular controller to link himself to this particular view. This controller is saying, I control the view defined in this layout. And activity main is this guy right here. Now notice here though, we get this thing called r.layout.activity_main. In Android, we have this R class. The R class is automatically generated by Android to have references to all of the widgets and layouts in your applications screens. I'll just put in parentheses here. There are other things in there too that we don't need to talk about. Just this class R, we didn't write. Every single time we make a change in our layout or something like that, that R class gets updated. And you'll see what I mean here in a little bit as we get a little bit farther into it, or actually maybe on Thursday when we get even farther into it. But between these 2 days, you'll see this guy in action. Okay, so this R class is automatically generated for us. So we don't mess with that. If we went in and we found the R class in the code, which we probably could locate under Java generated. Let's see, it's not there. It's not there. Do they hide it from us in here? Gradle scripts, maybe. Well, wherever it actually is, I promise you that if you went and looked in the folder, you would find an r.java file somewhere in there. But never touch it because Android Studio manages that for us. Okay, so what we're saying is go into that R class. Now, this is the name of a class. R dot. So layout must be what kind of animal is layout in the R class based on what you know from what we've talked about in here so far. Not from an Android thing. This is from a Java thing when we're talking about class methods versus instance methods, fields, all that stuff. So if R is the name of a class, what must layout be? And why? I could be asking the same question saying, if LOL was the name of a class, what must Woot be? Could be asking that exact same question. So if R is the name of a class, layout, first of all, must be a field. Why? Because we don't see any opening close parentheses. Okay, so he's a field. What kind of field? He's a static field, a class field. How do we know? Because he's being called with the name of a class. That makes sense? So those skills that we've learned in here are immediately transferable to something you've never seen before, because you're looking at this and saying, oh, well, what's R? Well, once you go and figure out what R is, and it's the name of a class, then you can say, oh, well, this must be a field in that class. And this must be a field inside of whatever this guy is. And since this guy isn't the name of a class, this must be an instance field. Those are guesses we're making, but at least we're able to look at this code and make some pretty educated guesses at the very least. All right, so what's happening here? This particular activity is setting his content view to be activity main, which we are designing over here. This is where those guys are linked. I'm going to make this text bigger here. So I'm going to say so you can see it, but it's actually so I can see it. So there's our Woot. I just made its font way bigger. Okay. Now, go ahead.
Why does it say activity main and not activity main.xml?
Because this activity main XML, this is our file, and this class is automatically generated. So inside of that class, it generates a layout section, and inside that, it generates a variable, a reference. This like holds a memory address to all of our actual layouts. So this is a variable name that corresponds to this file. So this guy here references this file. It's not the same thing as that file. So activity main is a pointer which points to where this XML file actually exists. So they share the first part of the name, but not the end, because this is a variable, this is an XML file. That make sense?
Yes, it does. Thank you.
But all this is magic. It all happens behind the scenes. So this is kind of usually when we talk about learning a new technology, and this goes way back to 200 when I said programming is the skill set. The language doesn't make any difference. So far, the things that we're seeing here that maybe seem funky have very little to do with Java. It's how does Android accomplish certain things. Right now, we're focusing on how does Android accomplish their MVC status. So the way that a layout can make itself available to a controller is through this R class. Okay. Now, if I chose to put something else in here, like different screen, I can then have this guy control a completely different screen. Instead of activity main, I can have activity main 2 and switch that guy right there. So I went into layout here and I right clicked. I'm going to say I want a new layout resource file. Let's see, what does that have under XML? Let's do a layout XML file. And I'll go ahead and make it a linear layout. And we're going to call this our backup layout. Oh, it doesn't like it to be called with an uppercase letter. Can it be called maybe underscores? Cool with that? There you go. All right. It's asking me if I want to add this to my Git. I'll go ahead and say yes. I'll remember that. So any new stuff I create in my file, I want to add to the Git repository. So make sure you do that. So here's my new layout here. I'll go ahead and here, I'll just drag a button out on this one. All right, so there's my button. And this guy is called backup layout. Now, if I run my program right now, it's still going to show me my original layout. I'm going to remember this. So it's saying, do you want to terminate the process app since I made changes? I'm going to hit terminate and just going to say, remember this. That way to automatically kill it and then restart it. Okay, so we're still back to our original application there. But why is that? It's because inside of main activity, I told it to go to activity main. But if I say r.layout.backup layout, so notice this guy is something I just invented, yet it's already in the R class. Okay, and it has this unique identifier that points to the this particular layout. Okay, so now I said, oh, well, this controller actually controls backup layout. So I run this guy again. Notice I now have my layout with a button. So this is how we programmatically link a controller. I'll go put it back to activity main. How we programmatically link a controller to a view. It's just one line of code. We set this activity to be the controller for this user interface because this is the content view of that activity. That make sense? Okay, so now what if we want something to happen? So that's how we link those two things. But I'm gonna go back into activity main here. I'll get rid of our backup layout, just close it. We're not gonna mess with that anymore. But here is my text field. All right, it's a text view is the kind of animal it actually is. Okay, when I click that, notice over here, it does not currently have an ID. I'm going to call it my text view. I'm giving this guy a variable name, if you will. So I name this guy my text view because what I want to do is I want to now programmatically change this text. So right now we can change this text by just double clicking on it. Can I double click on it and change it? Or I actually have to go over here. So I can change it to elephant. And now when I run it, it'll be changed, but I'm statically changing it. If I want to be able to change it as a result of code, maybe when a button is clicked or something like that, but right now we'll just do it with code. I need to have some way of referencing this text view inside of my program. So step one is I need to give this guy a unique name out here. So his name is going to be called my text view. Then I can go into my code and I'm going to create a text view variable. I'll call it my text view. And this guy is going to be equal to this dot find view by ID, r dot ID dot my text view. So I'm telling it to go and find a view with an ID. What ID? The ID called my text view. And store it inside of this variable of type text view. And now I can say my text view dot set text. And the text I'm going to set it to is hello world. And this is all happening on Oncreate. That is, it's happening before this thing is on the screen. So even though right now my design says elephant, when this activity links to that activity main inside of Oncreate, before this guy shows up on the screen, and I go ahead and I give myself access to that text view, So now I have programmatic access to a actual text view that lives on activity main. And then I'm setting that text view's text to hello world. And this all happens before it appears on the screen. So see how it says hello world now? Because I programmatically changed it. All right. So now let's go back and let's go ahead and let's add a button to this guy. And what we want to happen is when we click this button, we want this text to change. So that means we need to put a function inside of main activity. So I'll go down here and I'm going to write a function. This guy's going to be a public void. We're going to call this guy on. Well, I'm going to say on button clicked. You can name this guy whatever you want, but he has to take a view as a parameter. We're going to import view there. Same stuff that Eclipse used to do for us, import stuff that we're using. So we're importing a view as well as a text view, which is a specialized thing. So on button click, anytime we want to have an action that happens as a result of like an on click event, it has to be public. It has to be void. You can name it whatever you want, but it has to take a view as a parameter. You can name this view whatever you want, but it has to be a view. So what I'm going to do is inside of that function is where I'm going to actually get myself access to my text view and change the text. So I only want to change the text on a result of this function being called on button clicked. Okay. I'm not going to do anything else right now. Only when that function is called does it change the text. So right now my text starts off as elephant, and you'll see that it's going to stay elephant. So it's still elephant. I can go click my button all I want, nothing happens because I have not told this button that he's supposed to call that function. So now we're going to see this go the other direction. I have given myself programmatic access to this text view, but now I need to teach this button how to call code that's in my controller. So what I did is inside my controller, I wrote a function that followed a specialized rule. It has to be public, it has to be void, it has to take a view as a parameter. This will now expose this function to my interface builder out here. So when I click on button and I go to one of his attributes, which is called on click. So he has a common attribute called on click. That is what should happen when somebody clicks this button. When I hit this drop down, notice that my on button clicked function that I wrote shows up in here. It could have been called LOL woot. What it's called doesn't matter. As long as we wrote it to be public, void, and take a view as a parameter, he will get exposed to this interface and we will have him here as a choice. So now I set it to whenever this button is clicked, it should call the on button clicked function of main activity. And the on button clicked function of main activity says what? It says, go ahead and give myself programmatic access to the text view and then set its text to hello world. That's what it says to do. So now when I run this, it'll pop up. It originally says elephant. Now, when I click this button, it's going to now call that function and change it to hello world. All right, does that make some sense? So now we've gone both directions. We've said, how can I name a text view over in my interface builder to give it a unique name and then give myself access to that guy in code using find view by ID versus how do I write something in code that my interface builder becomes aware of so that it can automatically call this function as a result of an event. In this case, it's a buttons on click event. So that is write something as public, void, and takes a view as a parameter, and he will show up on this other list. And that's this on click thing. And you can change the text of a button and stuff. Where's on click? I'm lost right here. On click. Okay, so for your homework, write an Android application that creates a text box. Well, actually, we'll say text view. And sets, let's see, creates 2 text views. One for your first name and one for your last name. And creates 2 buttons when the first button is clicked. It sets the first name text view to your first name. When the second button is clicked, it sets the last name text view to your last name. You should import the code into GitHub as we did in class and submit the GitHub link along with the self eval. And just to show you the last piece here, I've made some changes to this guy now, so I can go up to my version control. I can go ahead and tell this guy I want to commit changes locally. So I'm going to say made changes to show MVC. And then this button says commit on it right now, but if you hit the little drop down, I can say commit and push. That'll commit it locally and push my update to GitHub. All right, so it's saying code analysis, 3 files contain problems, no errors, 6 warnings, blah, blah, blah. Pretty much always ignore this. It's looking up some of the other files that are currently in process in Android Studio. So just click commit and push when this pops up. And then it'll show me the changes it's going to make. So then just hit push. So now when I go to Android Studio, I'm sorry, when I go to GitHub here, notice I have some things that were changed like 21 seconds ago. So here's app, here's my source folder. That guy is now changed. Wrong thing here. It's in main is where your code is. And then here's my main activity. And you see it has this extra function in it that we wrote and all that stuff. All right, questions about what I'm asking you to do for homework for Thursday?
I have a question.
Go ahead.
Should the first and last name text views be empty beforehand?
It doesn't matter.
Okay.
Yeah, if you want to have them say first name and last name in there, then only fill it in with your actual first name and last name, When the buttons are pressed, that's fine. If you want to have them blank, it's fine too. Doesn't matter. Okay, then I will see everybody on Thursday.
Do you know yet if class will be online and in person on Thursday?
I think I'm waiting to hear back from the registrar's office. I think it's going to be online only. One of the things I think the university is trying to do, but it's not a public policy yet, is any classes that have fewer than a certain number of people that attend in person are going to go online. I guess in an effort to reduce the traffic on campus or something. I suppose if you have a strong feeling, send me a message, and I can use that as pushback that, you know, if somebody really, really, really wants to be in class, I don't mind coming in. So, so I guess send me a private message if you're somebody who really, really, really cares, given that I guess they're trying to reduce traffic. But as of right now, it looks likely it'll be online. But I will remind before class regardless.
Just so you know, I just found out today that my power is being shut off in my house for a couple hours on Thursday, so I might be a little bit late, but it should be back on at 11:30. I just wanted to let you know that.
Yep, no worries.
All right, have a good one.
Yep, take care.